Hello, good morning, students. Today we will study chemical properties of ethers. So, first type of chemical properties are laboratory test. So, ethers are neutral compounds in aqueous medium. They do not react with bases, cold dilute acids, reducing agents, oxidizing agents, and active metals. But they dissolve in cold and concentrated H2SO4 due to formation of oxonium salt. Now, how this oxonium salt is formed? We know general formula of ether is ROR dash. When it react with H2SO4 cold and concentrated, then it gives R OH plus R dash HSO4 minus. This is oxonium salt with sulfuric acid and ether. So due to this formation of this oxonium salt, ether dissolves in concentrated H2SO4, and this property distinguishes ether from hydrocarbon. So this is the first chemical property of ether. Then second chemical property of ether is reactions involving alkyl group of ether. So first reaction under this is formation of peroxide. Ethers combine with atmospheric oxygen and forms peroxide. This is example of peroxide formation reaction. CH3, CH2O, C2H5, this is diethyl ether. When react with atmospheric oxygen, that is for long contact with air, then the peroxide of diethyl ether is formed having formula CH3CH O single bond OH, and this CH is bonded to OC2H5 group. So this is peroxide of diethyl ether. All ethers which have exposed to atmospheric oxygen, they contain peroxide. It is very undesirable reaction because peroxides are hazardous. They decompose violently at higher temperature. So this is peroxide formation reaction. Next type of reaction of ether is reactions involving breaking of carbon oxygen bond in ether. Under this, first reaction is a hydrolysis, means reaction with hot dilute sulfuric acid. When ether is heated with hot and dilute sulfuric acid, then it undergo hydrolysis reaction. This reaction is observed for all types of ethers, and all ethers are converted into alcohol. And if there is aromatic ether, then it is converted into phenol. Equations are ROR is a ether react with HOH, that is H2O in the presence of H3O plus acid. It gives two molecules of alcohol. Similarly, if mixed ether is used, that is ROR dash, it react with H2O in the presence of H plus, it give this ROH plus R dash OH, that is two different molecules of alcohols are formed from mixed ether. Then next is aryl alkyl ether. So it contains the aromatic ring. When react with H2O in the presence of H plus, it gives alcohol and phenol. So this is hydrolysis reaction. All types of ethers show this type of hydrolysis reaction. Then next is reaction with phosphorus pentachloride. Ether react with phosphorus pentachloride, give alkyl chloride. and the reaction is ROR dash is a ether react with PCl5, then both alkyl group are converted into corresponding chlorides, that is RCl plus R dash Cl, and the side product is POCl3, that is a phosphoryl chloride. Next reaction of ether is reaction with hot concentrated acid. Here alkyl ethers react with hot and concentrated hydroiodic acid and hydrobromic acid, give alcohol and alkyl halide. Equation is ROR is a ether react with HX, that is hydrogen halide, give alkyl halide and alcohol. This alcohol again react with HX and give alkyl halide. So this is a reaction of ether with hydrogen halide give alkyl halide, or the by combining this equation, that is ROH is alcohol react with HX give RX plus H2O. So order of reactivity of this hydrogen halides is HI is more reactive than HBr than HCl. This is order of reactivity of hydrogen halides. Then next reaction of ether is aryl alkyl ether. Aryl alkyl ether. So this type of ether contains aryl group and alkyl group. They have stronger and shorter bond between oxygen and aromatic ring. Hence, aryl alkyl ether undergo cleavage of oxygen alkyl bond and give phenol and alkyl halide when treated with hydrogen iodide. Equation is, this is aryl group, that is the phenyl, and this is methyl. So name of this ether is methyl phenyl ether, commonly called as a anisole. When react with hydroiodic acid, that is HI, at 398 Kelvin, then this phenol is formed, that is benzene ring containing OH group, and the side product obtained is methyl iodide. So this is the reaction of this aryl alkyl ether with hydroiodic acid. The last type of reactions of ethers are, these are electrophilic substitution reactions in aromatic ether. Now, why ethers undergo this electrophilic substitution reactions? Because in aromatic ether, this alkoxy group is ring activating, and which activates ortho and para position. Therefore, this alkoxy group in aromatic ether is called as a ortho para directing group, and which is favorable for electrophilic aromatic substitution reaction. This is evident from the resonance structures of this aryl alkyl ether. So this is a general formula for aryl alkyl ether. Here the lone pair of electrons present on oxygen, they are delocalized in the aromatic ring from ortho position, then at para position, then at second ortho position, and finally again delocalized on the oxygen atom. So in this way, these 5 resonance structures we can draw for the aryl alkyl ether, which stabilizes this resonance structures and activates ortho and para positions. Similarly, this plus R effect of alkoxy group, that results in the increase in the electron density at para and both ortho positions, and this is observed in structure 2, 3 and 4, that is negative charge at ortho position, para position and ortho position. So in this way, this aryl alkyl ethers, they are more reactive at ortho and para position, and they undergo electrophilic substitution reactions. So first electrophilic substitution reaction is halogenation. Meaning of halogenation is a substitution of halogen group. Here we will study example of bromination. This is anisole, that is methyl phenyl ether, commonly called as anisole, react with bromine in the presence of non-aqueous solvent acetic acid. Then we get substitution of bromine group at para position and at ortho position. But here the product form is a measure which contains the substitution at para position because of less steric hindrance than at ortho position, and therefore para product is a major product. Here the para bromoanisole and ortho bromoanisole are formed. Next important reaction of this ether is Friedel-Crafts reaction. There are two types of Friedel-Crafts reaction. One is alkylation and acylation. This Friedel-Crafts reaction take place in the presence of anhydrous AlCl3. It is Lewis acid catalyst. Then the example of this reaction is, this is methyl phenyl ether, commonly called as anisole, react with methyl chloride in the presence of anhydrous AlCl3 as a Lewis acid. Then substitution of methyl group at para position. Similarly, substitution of methyl group at ortho position take place, and we get 4-methoxytoluene and 2-methoxytoluene. Here the para product is a major product and ortho product is a minor product. Then next is anisole, that is react with acetyl chloride CH3COCl. This is Friedel-Crafts acylation reaction. Again take place in the presence of Lewis acid anhydrous AlCl3 as a catalyst and give substitution of acetyl group at para position and substitution of acetyl group at ortho position. Again here the para product is a major product and ortho product is a minor product, so because of the steric hindrance. Next reaction is nitration reaction. Nitration meaning is substitution of nitro group. For nitration reaction, nitrating mixture is used, and nitrating mixture is a mixture of concentrated nitric acid and concentrated sulfuric acid. When anisole is treated with concentrated nitric acid and concentrated sulfuric acid, it gives 4-nitroanisole and 2-nitroanisole. But here major product is 4-nitroanisole than the 2-nitroanisole because of the steric hindrance. So para product is a major product in this reaction. And that is about the electrophilic substitution reactions of aryl alkyl ether. And the last part of this chapter is to study this uses of alcohol, ether and phenol. First is alcohols. Methyl alcohol, it is used as a solvent. This is the first use. The solvent for paints and varnishes. Then ethyl alcohol is used as an antifreeze agent in automobile radiators and also used as a solvent. So that is about the uses of methyl alcohol and ethyl alcohol. Then uses of ether. This earlier diethyl ether was used as a general anesthetic in surgical operations, but nowadays it is not used in as an anesthetic in surgical operations. Next use of ether is diethyl ether. It is used as a solvent for Grignard's reagent, fats, waxes, and oil. So these are uses of ether. Then uses of phenol. We know phenols are used as antiseptic and therefore they are used in the manufacture of soap. Similarly, phenol is also used in the manufacture of plastic like bakelite. So that is also important use of phenol, and that is about the uses of alcohol, ether and phenol. Thank you.